The second step in the copy process is called exposure. The exposure process includes the following steps: scanning, image processing, and image writing. Exposure. The image on the document is converted into a series of electrical signals which are collected in memory, forming the image data. Scanning sequentially exposes the areas of the document to light that is reflected to the CCD unit. Image processing mathematically manipulates the image data to achieve the desired effects, that is, reduction, enlargement, black and white reverse, etc. Image writing. The manipulated image data drives the laser unit to sequentially expose the OPC drum and create an electrical latent, invisible image. Scanning is the process of directing light at the original document and then converting the reflected light into electrical signals. The scanning process involves the sequential exposure of areas of the original document to light and then focusing the light reflected from those areas to the CCD. The various areas of the document are exposed by moving the first and second scanners along the length of the document. The copy lamp radiates light onto the document. The document is exposed and the light is reflected by moving the first and second scanners along the length of the document. The scanner is moved in discrete steps controlled by the scanner motor. This effectively dissects the document into many pieces or lines. Therefore, the scanning process breaks the original down into a series of discrete lines containing a discrete number of dots on each line. The size of each line depends on the amount of movement of each step of the scanner and relates to the scanner's resolution. Mirrors reflect the light through the lens to the CCD unit, charge-coupled device. The charge-coupled device, CCD, receives the reflected light, which it converts to electrical signals. The electrical signals are converted to digital signals. The digital signals are used to produce the data for the laser writing process. Detailed operation. The charge-coupled device, CCD, receives the reflected light from the original and converts each scanned line of the document into discrete dots using a row of light-sensitive elements. The output of each element is an analog voltage that varies proportionally with the intensity of the light it receives from the specific area of the original document. The analog signal from each CCD element is sent to an analog-to-digital converter circuit located on the CCD unit PWB, where it is converted to a specific number that represents that discrete voltage value. This number is a digital representation of that specific spot of the image and is termed the image data. As the entire document is scanned, each dot on each line is converted to a digital signal and sequentially stored in memory. The assembled data from the document is termed the page data and is a digital representation of the image on the original. The memory, which stores the page data, is located in the image control unit, usually a separate PWB. The image control unit, PWB, to achieve the desired effects, that is, the color correction, reduction, enlargement, and so on, can mathematically manipulate this data. Click on the highlighted image data. Color copiers, as in the example, have 3 separate lines of CCD elements. Each CCD line contains a separate color filter, one each for red, green, and blue. These filters allow only their specific color of light to pass to the actual CCD light-sensitive element. By monitoring the 3 CCD lines simultaneously, the CCD separates the R, G, and B contents of each area of the reflected light image. Therefore, after scanning, each dot on the original has 3 image data values associated with it, one value each for its red, green, and blue content. Black and white machines require only a single-line CCD, since images are printed depending only on contrast rather than specific color. Note, the human eye cannot see a latent image. The laser unit converts the image data sent by the PCU-PWB from image processing circuit to a laser beam and radiates to the OPC drum surface. The laser unit is composed of the primary system, which includes optical elements such as a reflective mirror, lens, cylindrical and collective types used to focus and direct the laser beams, polygon mirror motor, BD-PWB, which detects laser start timing, LD-PWBs, which are laser diode PWBs that control laser beam flashing and output values. The laser beam is directed towards the PGM unit with the help of the LD-PWBs and cylindrical lens. The laser beam from the PGM unit is then reflected onto the respective OPC drums with the help of the cylindrical lenses. Printing, latent image formation. Printing is the process of converting image signals from the image processor into optical signals and then directing these signals towards the organic photoconductor OPC drum via a laser unit. This action produces an electrostatic latent image on the surface of the drum. Formation of the latent image is performed in the following manner. The OPC drum's surface is negatively charged by the charge unit. The laser unit writes to black. This translates as follows. Black areas or sections of the original document containing an image will cause the lasers to radiate laser light onto the drums, causing the drum's potential surface to neutralize or become much less negatively charged. White sections or the non-image areas from the original document will not cause the lasers to radiate laser light onto the drum's surface. Thus, non-image areas of the original document will correspond to highly negatively charged areas on the drum's surface. Non-image areas on the original document, no laser radiation on the drum surface. The drum surface remains highly negatively charged. Image areas on the original document, laser radiates the drum surface is neutralized. The areas on the drum's surface which were exposed to laser light represent the latent image. These discharged or neutralized areas on the drum's surface now have the capability to attract toner. Note that the human eye cannot see a latent image.